Okay guys, so welcome back to another episode. So in this episode we have to make some adjustments, or rather redo the whole pathfinding for the monster. Because some of you guys pointed out that the monster gets stuck in the walls while moving towards the player. So I'll show you guys what I mean. First off, let's go into world environment and just change the ambient light to a brighter one. Whoops. So we can see something. And let's add a camera to the scene. Drag it in, move it up, and then just adjust its rotation so we can see it from a top-down view and make it current. Let's go. So, as you can see, here's the moving monster and he gets stuck in the wall. So, we will have to redo the system, and we won't be using a navigation node and get the path from this node. So we'll actually do a AStar algorithm, or rather, and we will use the AStar node instead to calculate the path on the grid. So let's make some changes. Move out the grid map from the navigation, and we can also remove the player and the monster and put them under the grid map. We can delete the navigation, and I think that is it. Under level as well, we have to remove this line and remove this one. We also need to get the new path for the monster and as well as for the player. And if we run it now, it should be working. Except for, yeah, of course. So under the monster script we have to make some some cleanup here. First off, we will remove the nav variable, and we can remove this one as well, this line, and we can, let's just remove all of this for now. We can remove this set nav, set target, we'll keep, get path. Okay, so we just return the path. I'm not even sure if you have this function, guys, but just remove it as well. Okay, so if target is null, we'll look at it, the path, get path to. Okay, we can, let's see, remove this one as well. And yeah, of course, path is null, so let's comment this out for now and run it. Okay, so now everything seems to work. We don't have any errors, and we have a monster who's just staring at us. Okay, so now for the fun part. Let's start off by creating a new script. So file, new script, and we call this, let's say, Pathfinder. So we need some stuff in this class. First off, we'll give it the class name Pathfinder, and we need a reference to the grid map. Initialize it with null, and we need a navigation ID. I'll soon explain what this is. And we need an AStar, or rather an AStar node. We override the init function. So we do need two more variables as well. So navigation points, we need an array of navigation points, and we also need a array of, or rather a dictionary of indices. And I'll soon give a brief explanation on what all of these stuff does. But anyways, so when we instantiate a Pathfinder class, now we need to pass two parameters. We need to pass a grid map, and that is of course the grid map that the monster we'll be working on. And we also need to pass a navigation ID. And the navigation ID is the ID of the tile. So if we head into grid map, you see we have two tiles for now. We have floor and we have walls. We need to tell the Pathfinder class what is a walkable floor, or what is a walkable tile and what is not. So the floor is of course the walkable tile, and this tile has an ID of 0, and the wall, no, sorry, the wall has an ID of 0 and the tile has an ID of 1, so we'll of course pass 1 to this function later on. So let's just set these variables. So self dot gridmap equals gridmap, self dot navigation ID equals navigation ID. And once we are at it, just call AStar equals AStar.new, just create a new object. And then we have to make some cool stuff. So first off, we need to set the navigation tiles. So we need to tell this class what tiles are walkable and what are not. So we start off by iterating through all the cells on the grid map for cell in grid map.getUsedCells. Alright, so we'll get an ID of the current cell that we're looking at. So grid map.getCell item, cell.x, cell.y, and cell.z. Okay, so we retrieve the current cell that we're looking at, and we check if ID equals navigation ID. So if this ID is the same ID that we passed as a navigation ID, this is a walkable cell. So we get the point from the cell, that is the cell.x, cell.y, and cell.z. Vector 3, this should be. So we create a new vector 3 out of the cell that we are looking at, and we set, or rather append, this point to the navigation points array that were declared up here. After that, we will create an index, and this is quite hard to explain because the AStar node, it links all the cells that it has stored by indices. So we need to create indices of each walkable tile. So we create an index and we pass it an indices.size, because by doing this we will always generate an unique index for each tile. So then we pass the point as the key for this dictionary, and the value will be the index. And then we have to pass the point to the AStar as well, so by the given index. So index and point. Alright? So this just tells the AStar that this index that we just generated belongs to this point, or vice versa. Alright, so now we have told the AStar what tiles are walkable. We will have to connect each tile. We have to tell the AStar what tiles connect with each other. So connect each tile. So this is done by iterating through all the navigation points. So for point in navigation points, we need to create a function to get the index by a given vector position. So we create a function func get index, and it takes a vector. And first we have to check if if it belongs in the dictionary. So if indices dot has vector, return indices. What is going on here? Oh. Return indices dot vector. Return null. Get point index. What is up? Ah, okay. So we need to. I'm sure we have another get index. Yeah, we already have a get index function. All right, back to the script and back to the Pathfinder. Okay, so if the key vector is within the indices dictionary, let's just return it. Otherwise, return null. And that is that. So now we need to connect our tiles. So first off, we get a index by get point index, and we pass in a point. And now we have to check the neighbor tiles of this tile that we're looking at. And this is done by creating a vector array, or we can name it to points, relative points equals pool vector 3 array. And we just pass in some vectors. So point.x plus 1, point.y, point.z. This is done 4 times because we need to check both to the right of the tile, to the left of the tile, and to the north and to the south of the tile. So point.x minus 1, and the last 2 will be looking at the z value. Alright, so once that is done, once we have created this relative points array, we need to iterate it. So for relative point in relative points. So now we get the index for this point. So var relative index equals get point index relative point. And if this is null, because this can be null, because we can go outside the grid, and then this would return a null value. So if relative index equals null, we just continue. And this just means that we do not continue what's underneath the if statement. We just go to the next iteration in the loop. But if it is not null, then we need to check if AStar has point. AStar has point relative index, and if it has that point, we just connect it. Connect points with the current index, the one that we have up here, and with the relative index. And once this is done, we'll create the function that will generate a path. So func find path from start to target. So we need to convert these 2 values will be in a global position rather than in the world position. We need to translate this to be in a grid position. So var grid start equals grid map dot world to map start. And we need to do the same for the grid end for the target. So var AStar path equals AStar. Then we call get point path as I told you earlier, AStar needs to know the indices to retrieve the path, or rather to retrieve the node. So this takes get point index, the grid start, and get point index, grid end. And this retrieves a path in the grid map. So we need to convert this to be in world space. So world path. Whoops. Oh my god. World path. For point in AStar path, we call world path and we append grid map map to world, and we call point.x, point.y, and point.z. So what this function is doing, it is first retrieving the two world positions, and we translate those into grid positions. We then get the path from the AStar by first getting the indices of each position, and get the point path between those indices. We then iterate through each AStar path, or rather each node in the AStar path, and we just create and we just append a world position based on the grid map position to the world array. And after that we need to, of course, return world path. And that is that for this function, I think. Let's just save it, and let's just remove all of those and head into monster, and under ready let's just try to create one of these. Var Pathfinder equals null, and we call Pathfinder.new. Let's just see if it works by, oh yeah, of course. We need to give it a grid map. Do we even have a reference to a grid map? No, we don't, but it's a direct child of the grid map. So we can do it like this by just saying get parent. What did I say? 1 was the floor. Okay, so now let's run it. Hopefully it won't get any errors, but we did. So non-existent function new. Oh my god, Pathfinder.new. Is this correct? Yes, it is, and everything works perfect. Of course, he ain't moving because we haven't retrieved any path from the Pathfinder. But that is something we will do now. So, in the previous episode, we retrieved the path every frame. We won't do that anymore. We will actually be because trying to get the path every second is not a good thing. Performance-wise, so we'll create a timer. Let's do it on ready. Var timer equals timer.new, timer.wait time. Let's search for a path every second. We'll add this timer as a child. We'll connect a timeout, self, find path timer, and we'll start the timer as well. We need to create this function, func. So once this timer is finished, we get the path. And we do have a path up here, yeah. So var path equals null. So let's just say path equals Pathfinder dot find path from my position. Global transform.origin to target global transform.origin. And if target is null or path equals null, then just return. Otherwise, we do have a path and we do have a target. Let's comment these out again, or uncomment this out, and run it. Oops, find path, non-existent find path, non-existent, okay, find path. We don't have a find path, we do have a find path, start target. What is up with this? What is up with this? Okay guys, I have no idea what happened. I just restarted my Godot and the path, this function could be called. I have no idea what happened. Anyways, so now we don't get any bugs or errors, which means we do have a path, hopefully. And let's just move along it. You know what? We should actually do something like this. Let's just remove this code. I just hate that piece of code. And under ready, just hit self.set physics process false. And once we have a target, self.physics process, no, physics process true. So this just means that once this is set, let's just run this physics process. Okay, so we do have a target then, and we might not have a path. Let's calculate the path, the first thing we do as well. Let's just call this function. Okay, so when we set the target, we set physics process to true, we just find a path and we just start moving along it. Bada bing, bada boom. So get path to, we can remove this function. Yes, we can. So move along path. We can remove this piece of code as well. So move along path. The first thing we need to do is we need to remove the first node in the path because that's our own position. So path.remove the first element. And once we've done this, we just see we need to check our distance to the first node in the path. We see if it's less than, let's say, 0.1. We just remove it because then we're very close the first node, or rather the first element in the path array. So we can remove it and then look for the next. But first we need to check if path.size equals 0. We just equals 0. Then we just return. If it's not equal to 0, we just get the rotation to the first element in the path, and we multiply it by speed, and then we just move and slide the velocity. Okay, so this should work. Hopefully. Let's run it and see what happens. No errors, at least. And here he is. Look at that. Okay, that is awesome. Let's go into our 3D scene. And let's just paint a bigger grid, rather a bigger maze. So let's just choose this. Oops. Is there a bucket tool in here? Grid map, bucket. Do we have a bucket tool? We do not have a bucket tool. Why don't we have a bucket tool? Okay, let me paint this and I'll be right back with you. Okay, so that is that. Our camera that we got in scene, let's just move it in and up, and so this isn't working by setting this to current. That is because we need to move it down a little bit. So, okay. We need to give it a full path, of course. Can't have any walls. So our player, I'll move the player to around there. So the monster starts here, it should go around and up and over there. Okay, let's see. And here he is walking like never before. And would you look at that? He's moving towards us. That is awesome. That is pretty awesome. Alright, so let's remove the camera, and this episode is getting a bit too long, so we need to wrap it up. So guys, peace out. And before we go, we can just get into our world environment and just lower the ambient color. And you know what, just until the next episode, just put out some more lights here and there, okay, so we can see something. Okay, so we have one light here. Yeah, so you can paint a grid and put out some lights and do some fun stuff. Until next time, peace out, and don't forget to subscribe, like, and do all that fun, cool, awesome stuff. So peace out.